Welcome to homework.
We have this 1,200-pound weight suspended from point C, and also at point C you have cables BC and AC applying a force to stabilize that 1,200-pound weight. You need to find the value of alpha such that the tension in BC is as small as possible, and then we'll calculate the tension in BC. So I already have my force triangle here, and let's go ahead and go through some, let's see, our angles here. So we know A is 5 degrees. C is going to be, well, if this is a 90-degree angle, C will be 90 degrees plus alpha. And that means B is going to be, all right, so we can see that if this was a right angle here, knowing that this adjacent angle is going to be 5 degrees. So we have 85 degrees left minus whatever alpha is going to be. So 85 degrees minus alpha. Okay, so let's use the law of sines, and we can say that we'll use the 1,200-pound side first. So the sine of B over 1,200 is equal to the sine, draw that better there, the sine of C over the tension in AC, which is also equal to the sine of A over the tension in BC. Let's focus on tension in BC and the 1,200-pound force. So B is the sine of 85 degrees minus alpha over 1,200, and we'll say it's equal to the sine of 5 degrees over the tension in BC. Well, if we solve that for the tension in BC, we get that it's equal to 1,200 times the sine of 5 degrees over the sine of 85 minus alpha. Okay, so what does that tell us? Well, we know that as the denominator here, the sine of 85 minus alpha, we know as that value gets larger, then the tension in BC gets smaller. So the largest this can be is 1, and that's when sine, well, that's the sine of 90. So 85 minus alpha equals 90 is when that's equal to 1, because then you have sine of 90. So then the tension in BC will be as small as it could possibly be, because as this angle here decreases, then the sine of that angle also decreases, causing this whole thing to increase. So that means that if you solve this for alpha here, that means that alpha must equal negative 5 degrees. Let's do that better. Negative, wow, what's wrong here? Negative 5 degrees, there we go. So alpha is equal to negative 5 degrees in order to minimize the tension in BC. And then all we have to do is calculate the tension. So if we plug in alpha to this equation, tension in BC is equal to 1,200 times the sine of 5 degrees over the sine of 85 minus a negative 5 is going to give us 90 degrees. Then the tension in BC is going to equal 104.6 pounds.